All right, Allie, help me on number one. We're trying to find this missing angle here, theta. What was your thought process?
So you're given opposite and adjacent with this tangent. So 6/10, and then put tangent, theta negative, or power of -1, and then we got 30.9.
You guys agree? So tangent is opposite over adjacent, so she just did the inverse tangent of that. Boom, got that. Now, can I show you technically how we would do this? She kind of jumped a step, which is just fine, but just for our thinking of this lesson, we would start by saying, so tangent of theta is equal to what? 6/10. And then what we would do is we'd say, hey, what we're trying to figure out here is we want to undo that tangent. I want to take the inverse tangent of both sides. So that's how we got to this step here, right? And so the theta is equal to the inverse tangent of 6/10, so theta is about 30.9. Awesome job, thanks, Allie. Let's go to number 2. That was Micah. What did you do on this one, Micah?
So we're trying to find theta, and we are given the adjacent and the hypotenuse
Yep.
sides. So we would just do the cosine of theta is equal to 13/14.7.
Great. And then what from there?
And then we would do the inverse of cosine.
On both sides. What happens when you do the inverse cosine of cosine?
Cancels out.
Good job. So what is the inverse cosine of 13/14.7?
I got 27.
You guys agree with that? Okay, so this was a review of stuff we've done earlier. It's a review of stuff you've done in other years. What we're going to do today is talk about how to do this on the unit circle. Woohoo! So if you don't have it out already, get out your blank, not your blank, your completed unit circle. And we'll talk about how to find inverse trig ratios, or in other words, angles, on the unit circle. And it's not too bad, okay? As long as you know your unit circle, you'll be okay. Which, by the way, so today is a B-day. We are going to cover 4-7. I'll see you guys again on Wednesday, and that will be 4.8. Then we have 2 A-days in a row, so distance learning A-day Thursday. Then we don't have school Friday or Monday. We'll have an A-day on Tuesday, so I won't see you guys until Wednesday. That's like a whole week, okay? Now that Wednesday, we're going to review all of Trig, and then that Friday, which is a distance learning day, you're taking the test at home. So just make sure that you've stayed up to speed with any of your homework, and if you need any help, this week is a good week to do it, because I have parent-teacher conference after school on Tuesday and Wednesday, but it's not till a little bit later, so right after school I should be available, okay? Which, by the way, if you want to come, I sent out an email with instructions. Did you get it? Oh. You're like, if it's from Solberg, I just ignore it anyway, so. All right. Okay, I want you to talk to your neighbors about these questions for just a minute. See if you can refresh your memory. you've had a second to think about this, let's come together. Show me with your hands, what does sine slash cosine look like? Sine and cosine is like this. Does that pass the vertical line test? They go, passes. What does that mean? It's a function, right? So sine and cosine are functions, right? For every x, there's no more than one y. That's what it means. But does this pass the horizontal line test? If I were to scan it this way, it fails. What does that mean? Think back to earlier this year when we talked about the horizontal line test. If it passes a vertical line test, it's a function. If it passes a horizontal line test, what? Do you remember? If it passes both, we call it one-to-one. And one-to-one meant not only would its function, or it would not only would the original graph be a function, but so would its inverse. Remember that? So if it passes horizontal line test, it means its inverse would be a function. Well, sine did not pass the horizontal line test, so what does that mean? No, it doesn't. It has an inverse, but its inverse is not a function. Let's try this for a second. Show me secant and cosecant with your hands. What does that one look like? Remember? Secant, cosecant. We had a u, and then flipped u, and then u, flipped u, right? We just put them on the peaks and valleys of sine and cosine. Is this a function? Does it pass the vertical line test?
No, it's not vertical. Wait.
There's vertical asymptotes, true. But does it ever repeat itself going this way? They're always slightly different, so it passes that. Does it pass this way? No, it doesn't, because it's got all those different u's that's going to intersect with, so nope. Lastly, show me tangent. Do you remember tangent? It's the snakes slither in which direction? Good. What about cotangent? Snakes slithering down. Good job. Does it pass the vertical line test? Yes, meaning it's a function. Does it pass the vertical line test? Or, sorry, the horizontal line test, yep. No, which means its inverse is not a function. Okay, this is something we learned towards the beginning of the year. So, let's just fill it in right here. Do they pass the vertical line test? They do pass the vertical line test. I'm going to put a smiley face or a check mark. What that tells us is that they are functions. But then, do they pass the horizontal line test? They don't. So we're going to do this one in red because it's... Hey, you're supposed to be red. And what that means is their inverses are not functions. Now, do you guys remember how we would get an inverse? For example, when we were graphing logarithms, what I told you to do instead was to find its inverse, graph its inverse, and switch back. So what was the first step with finding an inverse? Give you a clue, we went. Does that mean anything to you? We switched x and y, thanks Brandon. So when I'm finding the inverse, I switch x and y, solve for y, and then that's the inverse, okay? Is it a Monday? Did you not get some caffeine this morning? Okay. So guys, is this sine or cosine? I mean, there's a big label that says sine, so you can get that one, right? Okay. Now, here's sine. It passes the vertical line test, does not pass a horizontal line test. Now, what we're going to do is we're going to say, hey, maybe we can't take the inverse of the entire sine, but what if we restrict its domain? What if we just look at part of sine? Could we make it so it's one-to-one, meaning that it passes both the vertical and the horizontal line test? Also with that, we want to choose it strategically so we represent all the y values. So what I'm going to do here, I'm just going to give you the answer, and you're going to find it for other ones. But if I were to go and highlight and say, you know what, let's just take it from this section here to right there, and say, I'm only going to look at that piece of sine. It still passes the vertical line test, but now does it pass the horizontal line test? It sure does. So what that means is that now it's 1-to-1. If it passes the vertical line test, it means it's a function. If it passes the horizontal line test, what does that mean? Its inverse will be a function. And yep, that's what we're going to do. Now, before I do that, what are the bounds here? Okay, so we stop at pi halves. Where did we start here? Negative pi halves. And that's kind of important, and you're going to see why here in just a second. So right here, this is our graph of sine. Okay? And what we did is we just started at negative pi halves, which was actually negative 1 there. And then it's kind of going up here, and we said, let's just take a piece of it from negative pi halves to pi halves. And what we're going to do is we're going to switch all of these x and y values. So this is plain old sine, and then if I switch all the x and y's, this is its inverse. So this is sine of theta, and this is the inverse of sine, sometimes called arc sine. Are they both 1-to-1? Do they pass both the vertical and the horizontal line test? Yes, and that's cool. Now, the reason why this is important for us to realize is because the inverse of sine is only going to be defined from here to here, which is from negative pi halves to pi halves. Okay? Now, just a couple of notes that I want to talk about here. Let me just put a little note here. The inverse sine is not the same thing as cosecant. When we're talking about cosecant, what is that referring to? What do we call cosecant, secant, and cotangent? Reciprocal. Is reciprocal the same thing as inverse? They are not, but sometimes people like to associate those together, but they're not. So just remember that if we're doing sine to the negative 1, this is inverse. And we use this to find missing angles. Whereas cosecant, this is reciprocal. And I don't know if I spelled that right, but it's okay, because we're a math class. Still like you to spell correct, but I'm lenient there, okay? Okay, and I kind of went over it on this page too. So now here's the deal. The inverse sine, also called the arc sine, it's the unique angle y in the interval negative pi half to pi half such that sine of y equals x is the inverse sine or the arc sine. Now, it's only defined, so here's arc sine, it's only defined between where? Negative pi halves and positive pi halves. What two quadrants are those? 1 and 4. Now, where you have to be careful is when I look at my unit circle, I see angles in unit 1 and 4, but it's showing me from 270 to 360, and we actually want it from 0 to negative pi half. So it's going to be, we're going to have to do some calculations for our coterminal angles here, but it's not going to be too bad. Big thing to just remember is inverse sine is only defined on the first and fourth quadrant. Okay, you got that part? So here's what you're going to do. Find the exact value of each expression without a calculator. Notice this is saying sine to the negative 1 is 1/2. So it's not just sine, it's the inverse sine. What this is saying is look at your unit circle, and where do you see that the sine is 1/2? Now sine refers to which letter? Because it's your heights. Good job. So I want you to take a second with your buddy, and I want you to look around the unit circle and say, where is the y, or the height, 1/2? Go. Charlie, shout out. What did you find here? Where do you see that? Which angle is the sine 1/2? All right, so let me start with 30. If I look at the coordinates at 30 degrees, that's a positive square root of 3 over 2 for the x and 1/2 for the y, right? So, is the sine 1/2? Is the y value 1/2? Yeah, that's true. Now, there's other places where we could see that. Now, at 330, we're going to get negative 1/2, right? Now, in this case, we didn't want negative, we wanted a positive. But is there somewhere else where we could find a positive? Which angle? 150. So if I look at 150, which is going to be this angle right here, I see the coordinates, the x is negative square root of 3 over 2, and the y is a positive 1/2. So what we were trying to get was a positive 1/2, and sure enough, I see it right here and right here. Now, here's the problem. Only one of those is correct. Any guesses which one? Why do you think it's 30, Hiram? You're right. So this is when we're going to go to the next page, the previous page, and say, hey, where was inverse sine defined? And we would say, which quadrants? First and fourth. More precisely, we would say it's between negative pi halves to pi half, which is another way of saying between negative 90 and 90. So which of those angles is between negative 90 and 90? 30 or 150? You would say 30 degrees. Now what you're going to do to check this is you're going to go on your calculator and you're going to put in sine to the negative 1 of 1 over 2. Make sure your mode is in degrees, because if you're in radians, you're going to get weird answers, okay? Did you get 1/2? Or sorry, did you get 30, I meant? Okay, cool, that's how it works. Okay, let's try the same thing now with p. Inverse sine is negative square root of 3 over 2. So again, what you're going to do is look at your unit circle and say, hey, for which angles do I see that the height, or the y, is negative square root of 3 over 2? I'll give you a second, find that. All right, Ofa, tell me what you're thinking. Where do you see this? All right, so let's go to 300 degrees. That's right here. The coordinates there are the x is 1/2 and the y is negative square root of 3 over 2. Awesome. Is there anywhere else where we see the y value is negative square root of 3 over 2? 240. We also see it. The x is negative 1/2 and the y is negative square root of 3 over 2. Okay, so we had two angles here. The first was 240, and the second was 300. Which of those is going to be the angle that we're going to use? The 300. However, we're not going to say our answer is 300, because remember our picture here, it's between negative 90 and 90. So what's a coterminal angle of 300 that would be between negative 90 and 90? Negative 60. How'd you get that?
Big brain.
Big brain. You just took off a rotation. And there we go. Put that in your calculator, guys. Is the inverse sine of negative square root of 3 over 2? Plug that in, and do you get negative 60? And what'd you get? Is it negative 60? Okay, cool. That means you did it right. Good job, guys. Okay, does that make sense? You're basically going to be looking around your unit circle, and if it's inverse sine, you're saying, where is the y value then? So then make sure if you're answering it in the first or fourth quadrant, between negative 90 and 90. Now, C is a little bit tricky here, because it's saying, where's the inverse sine pi over 2? You're like, okay, look at your y values. Do you ever see that the height is pi over 2? Do me a favor on your calculator, put in pi over 2. Let's get a decimal approximation. What is that anyway? Say 1.57? So we're saying, when will the height of this circle be 1.57? Well, what's the tallest this circle is going to get? 1. So are we ever going to be 1.57? So what do you think our answer is going to be? Good job. Why don't you try it on your calculator? Put in inverse sine of pi over 2. Doesn't like it. Did it say undefined? Error, domain. That means it's undefined. All right, cool. There you go. That's how we do inverse sine. Okay, now let's look at ones where it's maybe just a little bit trickier, okay? So here's my question. If I take the cube root of a number and I cube a number at the same time, what do the cube root and the cube do to each other? Kind of cancel each other out, so that just becomes x, right? And that is true all the time. Now, what about if you do the square root of a number squared? Will that always be x? The answer is it could be, right? But it also could be a negative x. Let me show you what I mean. Let's say my number is negative 5. What is negative 5 squared? What's the square root of 25? So is it possible that we could start out with a number and get something different if I do opposite operations? The answer is yes, so you kind of have to be careful here. Sometimes they just cancel out and we're happy. Other times it doesn't work out quite as easily, okay? Because we have to just keep in mind where sine is defined, inverse sine is defined, okay? Let's try doing D and E, okay? So on D, it says to do the sine of pi ninths. Now, then it wants us to say, what is the inverse sine? So this is kind of saying, hey, what is the height at pi ninths? And it'll give us a height. And then the inverse sine is saying, hey, what angle gives me that height? So do you see how they're kind of opposites of each other? Guess what's going to happen here? What do the inverse sine and sine do to each other? Cancel, so your answer is pi ninths. That was fun. Now, let me just go over why it cancels here, okay? If we look at pi ninths, which quadrant is pi ninths going to be at? Do you see where pi 6 is? So it's going to be less than pi 6, right? So it's going to be, let's just say it's right there, this small angle. I'm going to draw it in right here. So let's just say that angle right there is pi ninths. Now, when I take the sine of pi ninths, what am I going to look at? I'm going to say, what is the height there? So if this angle right here is pi ninths, oh, that made a weird squiggle. Then when we take the sine of it, we say, hey, what is the height right there? So this y value is going to be the sine of pi ninths. But then what we're going to do is when we do the inverse sine, we say, hey, which angle gives me a height of this y value? And we would say, well, it was pi ninths, right? Now this worked out because why? Where is inverse sine defined? 1 and 4. Was this angle in 1 and 4? So it worked out just nice. So in this case, I could just cross it out. The answer is pi ninths. Now let's look at E. It's going to be a little bit different here. When I'm looking at the inverse sine of the sine of 5 pi 6. First off, is 5 pi 6 on your unit circle? Which quadrant is it in? The second one. So let's draw a picture. Pictures always help us here. Here's my unit circle. It's not pretty. That's a really bad unit circle, I'm sorry. But you're going to get the idea here. No, we're going to redo it.